In this video, we're going to be discussing assemblies and joints. So we're going to learn how to access and add new joints using the API. So let's go ahead and start off here in the Fusion 360 API object model. If we zoom in, we're actually going to see that joints are really easily accessible. So once we come down here through the design and we have the component, we can come over here and access the joints collection. Now notice there's a lot of different joints collections. We'll talk about that in a little bit. But joints are actually pretty complicated. So as we walk through this, I'm actually going to pull up my code and we'll walk through it. And as we're looking at the help documentation, we'll look at the implementation into the code. So first of all, notice that in my code, I have my application. I come down and I get my root component. So in order to access the joints collection, all we do is root comp.joints. So this is the section of code that we're going to be looking at. So first of all, I access the joints collection. So moving on, if we go into the help documentation and we grab into joints, notice that if I want to create a new joint, I can just use the method add. So here, in order to add something into my joints collection, I need an input. So here in the code, this is the method I use at the very end. I need a joint input. But let's go ahead and look at what that joint input is going to need. So going into the joint input, notice first of all that we're going to need two main things with the joint input. First of all, we're going to need to create it. We need to create the input. And secondly, we need to define what kind of joint it is. So let's look at this first. So once I've created a joint input, I need to define what type of relationship it has. I'm going to be doing, let's see, over here in the code, it looks like I have it as a rigid joint. So here, all you do is you just have your joint variable. Once it's created, you just do dot set as rigid joint motion. So that's after it's created though. So let's go ahead and look at what we need to create the joint input. So if we click on here, notice that we need a joint variable dot create input, and then we need two geometry origins, geometry or origin 1 and then geometry or origin 2. So before we dive into that, let's look at this in the code. So first of all, I did a joints dot create input here, and then once I created that joint input, I did joint input dot set as rigid motion. So we're kind of working backwards here, because as we move backwards, we can see all the things that were needed in order to plug in and to create these things. So in order to create the input, I needed two geometries. So let's read a little bit about this. First of all, so the description of these geometries as the parameters needed to create an input is a joint geometry or joint origin. So let's go ahead and go over here to the left and look up. We could either do joint origin. I'm going to actually be doing a joint geometry. So let's learn about that. So in order to do a joint geometry, it looks like we're going to need to be able to create one depending on what type of geometry we're using. So it could be a couple planes. You could create a joint geometry by a curve, by a point, by a face, or a non-planar face. This is the one that I'm going to use. Since I want to do two cylinders together, I'm going to join two cylinders together. They're both non-planar, so I'm going to use this method to create a joint geometry. So notice that in order to create the joint geometry, I do adsk.fusion.jointgeometry.create by non-planar faces. Then I need a face, and then I need to tell it which key point type. So let's go ahead and look at that in the code. So here, right before I pass in my geometry, I needed to grab the geometry. Here I did it just as we said, create by non-planar faces. And then here we needed the face and then also which key point type. So I've created the key point types here. Both of them I just selected as middle key point. But notice that if we click on this, you could also do end key point, center key point, or start key point. Both of mine are middle key points. And then notice here that I also need the faces. Now these faces have to be a little bit different than what we're used to. They need to be, well, let's actually look at it in the code here. So the face, we need it to actually be a brep face. So we can't just create a face off of a component. We actually need a brep face. It's a body representation, and it has to come from occurrences. And so let's look at that. So I have two different faces that I have. I have a proxy face and a selected face. So let's go ahead and look at in the code. One of them I actually just asked the user to select a face. So I gave him a message, told him to select a cylinder, and then I did UI.selectEntity, which we learned about in a different video. I let them choose a cylinder, and it has to be a cylindrical face. That's going to return a selected item, an entity, and then I grab that entity and I grab the base object. And then once I do that, I can get the BREP face off of that object. So that selected face, now that it's been returned as a BREP face, I'm going to pass that in. And this line of code is basically grabbing that face and telling it it needs to be a BREP face. So the second one that I grabbed, this face proxy, is actually going to be coming from something that we imported. We learned about in the previous video. I've imported a little pulley. Now from that pulley, I have its component here. So I grab the component, and then to get the face, I grab a certain face, pulley face. Now this pulley face could be represented. It needs to be represented for an assembly context. So in order to do that, we do pulley face.create for assembly context, and then I tell that face what type to be, and then I pass that in, and so now we have the geometries, the inputs, and then we can create the joint. So let's go ahead and run through that from the very top. Now remember, we need to grab the joints collection, and in order to add something to the joints collection, we needed an input. So we created the input by using two different geometries. The geometries needed two different faces, so that's what we grabbed here and up here. Once we have the joints input, we define what type of relationship it has, and we did that there, and then we can pass the input in and it creates that joint. So it's kind of a lot going on. Let's go ahead and look at it in the code though. If I run this, we'll see how it creates the pulley. It's going to then ask me to select a cylinder. I'll select a cylinder, and then it pieces the two together. So you'll need a lot of the help documentation is really useful, as there are a lot of different methods and a lot of different things that you need to pass in. But this is just a quick overview, and we hope that you can get a little bit more familiar with assemblies.